All right, so what I'm going to do is some practice problems to help you figure out how to solve half-life equations. So we are going to use the example of carbon-14. So remember we said that carbon-14 has a half-life, so T 1/2 equals, it takes 5,730 years for half of this substance to decay. So that is the half-life of carbon-14. Now our first question says, how old is an artifact if 25% of the carbon-14 is remaining? So basically we have to determine how many half-lives have occurred. Well, let's assume that we're starting with 100% of carbon-14 in our sample. To determine the number of half-lives, we have to determine how many half-lives will it take to get to 25%. Okay, well, half of 100% is 50%. So when our sample has decayed from 100% to 50%, that's going to be one half-life that's occurred. But we don't have 50% remaining, we have 25% remaining. So what would half of 50% be? Well, if we took half of 50%, that would give us 25%. So basically 2 half-lives have occurred since our sample started to decay. Well, if 2 half-lives have occurred, we know the length of 1 half-life, so we can times that by 2 to figure out the age of our sample. So if we do that, 5,730 times it by 2, we can figure out the age. So again, we're going to take the half-life, 5,730 times it by 2. The age of our artifact is 11,460 years old. That would be the answer to this first problem. 11,460 years old. Okay, that's how we solve practice problem number 1. All right, let's take a look at our second practice problem. Our second practice problem says, how many half-lives have passed for an artifact that is 10,000 years old? So this one's a little bit different because we're given the age of the artifact in the problem. We know that it's 10,000 years old. So how do we determine the number of half-lives that have occurred? Well, let's think about what we know. We know that the length of one half-life is 5,730 years. So if I take the total age of my artifact and I divide it by the length of one half-life, 5,730 years, okay, that's going to give me the total number of half-lives that have occurred. So if I plug this into my calculator, 10,000, sorry, there's kind of a glare there, divided by 5,730, which is the length of one half-life. This tells me that 1.74 half-lives have occurred. So to answer this question, how many half-lives have passed? The correct answer is 1.7. We round up 5 half-lives. That's how many have occurred. That's how we solve our practice problem number 2. Now let's look at our third practice problem. What percent of carbon-14 is remaining after 25,000 years, and how many half-lives have passed? So we have 2 questions that we have to address here. We have to figure out the number of half-lives that have occurred, and we have to figure out the percent remaining after this amount of time. So let's start by figuring out the number of half-lives. If my artifact is 25,000 years old, we're going to start with what we know. And to figure out the number of half-lives, we divide it by the length of one half-life. Well, what was the length of one half-life that we were given? We refer back to the problem. One half-life is 5,730 years. So we're going to divide that by 5,730 years to figure out the number of half-lives. So we pull out our calculator, 25,000 divided by 5,730 gives me approximately 4.36 half-lives that have occurred. So that's the first part of our question. 4.36 half-lives have occurred. Okay. All right, so we've solved for the first part of our problem. We figured out the number of half-lives. Now let's solve for the second part of the problem. To solve for the second part of the problem, we need to refer back to our equation. X equals n times 1/2 to the power of t, where n is our initial amount, 1/2 t is the number of half-lives. Well, what is our initial amount that we're starting with here? If we start with 100% in decimal form, 100% is just the number of 1. So we're going to plug in the number 1, times that by 1/2, and raise it to the power of 4.36. Now, where does this 4.36 come from? Well, in our previous problem, we determined that we had 4.36 half-lives. So that is the number of half-lives, t. So we're going to plug in for t, the number of half-lives, 4.36. So now when I put this into my calculator, I'm going to have 1 times 1/2, or 0.5, raised to the power of 4.36 half-lives, close my parentheses, and this is the percent that remains, 0.0487%. Okay, so if we change this into a percentile form, we knew the decimal place over 2 spots. We change this number into a decimal, it's 4.8% that remains. That's what the question was asking us for. So this is just this number written as a decimal form. We move the decimal place over 2 spots. Okay, so the correct answer is 4.8%.